What's going on, everybody? Boris here at the Ecology Design Studio. Welcome to episode 10 of this Java tutorial series where we try to learn Java together. Today we're going to learn about inheritance, constructors, and subclasses, and we will pick up good software development practices along the way. We've got hundreds of lines of code to write, so let's get started right away. We're going to create a program that has two employees. One works on commission and one has a base salary plus commission. We're going to see how the latter borrows from the former through inheritance. We'll also see that we want variables in the parent or superclass as private as opposed to public or protected, so that subclasses in different packages and classes can't call and modify our variables. What we want to do is include non-private methods that access private instance variables, ensuring that objects of the class remain in a consistent state. You can probably see where this is going. Instead of referencing the variable itself, we're going to reference our set and get methods and do this during that stage of our program. So let's jump right in. Go ahead and open NetBeans IDE, open a new package, a new project. Call it whatever you'd like. I've called it Constructor Test, or actually I've called it Constructor Application. And the package is called Constructor Test, with the main class called Constructor Test.java. And you can see this here. We have public static void main string args. We're going to have three different files in this program. We're going to have three different new files. Of course, our main class. Each Java program has to have a main class. The first one actually is going to be commission employee.java. That's going to be your superclass or a parent class, where we're going to declare how much an employee makes on commission. And then base plus commission employee, you can call that commission employee plus base or whatever you'd like. This is actually going to extend class commission employee, and we're going to see that later on, but for now let's focus on this first one. Remember how we talked about declaring variables as private so that other instances or other classes can't access them and modify them. That's a good software development practice that we're going to get started on right now. And it's going to make more sense once we finish the program and take a look at what's going on. And also towards the end, I'm going to give you a demonstration of what not to do of a program that uses public or protected variables instead. And we're going to see the difference. But let's get started. Private string first name. And you can kind of guess where this program is going. We're going to have first name, last name, social security number, gross sales calculated by gross weekly sales, and then commission rate, which is going to be a commission percentage. We're not going to use user input right now. I mean, to make this program really useful, we're going to maybe have user input. We're going to import the scan, the system, the util.scan from the Java API. And then we'd have the user input the name, the social security number, and then go that route. However, this is just as a demonstration to show how inheritance works in Java, so we don't need to do that. Maybe we'll modify it later on to be more useful. But for now, let's declare all our variables as private. And they're going to be private strings, last name, and social security is a string. Social security number. Now, gross sales is going to be a double. Gross weekly sales. Private double commission rate. Commission percentage. Okay, and now we're going to have a 5-argument constructor. And this constructor is going to do a specific thing. It's going to be public commission employee, and it's going to basically input our string first, string last, string SSN instead of social security number, and then double sales, double rate. And then during the set and get methods, we're going to declare those. So instead of typing, social security number, we're going to just type in SSN like this. So this is going to be 5 argument constructor. Public commission employee. Of course, getter brackets. And string first, string last, string SSN, double sales, and I don't want to, I want to split this on a different line. String SSN, double sales, double rate. Okay. And again, opening and closing brackets. What we want to have here is an implicit call to the object constructor, and it's going to occur right here. So let's do implicit call to object constructor. First name equals first. You might have been wondering, yeah, there you go. You might have been wondering why we were calling it first instead of first name. It was because we're simplifying it here. First name equals first. Last name equals last, and so on and so forth. Social security number equals SSN. Set gross sales. And here we're validating and storing gross sales. Now let's do set commission rate. And here we're validating and storing commission rate. They might be wondering why we're getting errors and it's coming up as, you know, cannot find symbol method set gross sales, because we don't have a set and a get method yet, but we're getting there. And here we're going to add a little something. We want to print out which constructor we're using. We want the program to keep track of which constructor we're on. And we're going to use a print statement to do this. So we're going to use system.out.printf. Now, you know, real programming, you probably will never do this. This is just for our purposes. That way we can keep track of what's going on, which constructor is being called, in which order during execution. So printf, we're going to do parentheses, \n, commission employee constructor, /n, %s as a string placeholder, /n, comma, this. And we'll explain why this in a second. And here we're ending 5-argument commission employee constructor. The word we typed this will implicitly invoke method toString of the object being constructed to obtain the object's string representation. We'll get to see toString in a minute. This constructor will output text upon its invocation. Now let's focus on our set and get methods. And we're going to set first name. This is a bit tedious, but stay with me. Public void set first name string first. And of course, opening and closing brackets. And in this method, we're going to do first name equals first. So we're setting first name equal to first. And we're going to end method set first name. You might be wondering why I'm taking painstaking amount of time to do methods and, you know, annotate closing brackets. You might think, you know, we'll be saving time if we skip this step. But honestly, those of you that have programming experience already know that if you write code and then come back to it, even a few days later or maybe a month later, it'll be like reading another language. That's why we want to make sure that we annotate everything properly. That way, if we come back to it, or if somebody else maybe picks up the program, they know exactly what's going on throughout the code. So documentation and commenting definitely help. We're not going to deal with the IT side of it, of how we document software development at the moment. So comments are what we have to ensure program stability. And I do recommend you keep some of these programs that we're going through, because we will revisit them at some point in the future and maybe make alterations. But I'll always provide the code that we use in the beginning and the end of a program if I'm referring to a program we've worked on in the past. Now let's continue. Let's return first name, and then that means we're using our get method. And we're going to do return first name. So public string get first name. And this is what I was talking about when we talked about give me 1 second. When we were talking about good software development practices, declaring the variables as private, because we're using public classes here. Take a note, public string get first name. So instead of referencing the variable first name, we're declaring this variable private, which basically means it's finalized. It's a final variable. The value of it is not going to change. And then down here, we're using the get method as a public, which means any method or any instance can access it from maybe a different package or a different class. And let's do return first name. Where is it? Return get first name. Or not get, return first name. A little confused there at the end. And we're going to end this method. Now we're going to set and get the last name. Actually, what I'm going to do is basically copy and paste this, because there's no point in reinventing the wheel and writing it over and over and over again. So let's do this. Set last name, and then return last name. So all we have to do is change first to last. Set last name equals last. Get last name, return last name. And there you go, much easier. While we're doing this copy and paste method, we must not forget to change the arguments here. So instead of string first, we need to have string last. See that this was underlined red. And now we're in the green. Now let's do social security number, sales amount, gross sales, commission rate. Like I said, it's a bit painstaking and tedious, and I tend to get confused because, set this, get this, set this, get this. It continues on, especially if we have many variables. But let's push through it. Set social security number. And now in this one, we're getting the social security number. We set the social security number. Now we're doing our get method. And forgive me if I don't talk the whole time. I'm concentrating on just not making any errors or any silly errors. That way we don't have compile time errors. But public string, get social security number, again opening and closing brackets, and then we're going to return social, and watch capitalization too because that's very important. Social security number. I'm gonna start abbreviating for the comments. And now let's do set gross sales. Public void set. And notice that all the set methods have the keyword void, meaning they don't return anything. It's the get method that gets the void word replaced with string or double. In this case, for gross sales, is going to be double, as we'll see in a second. But right now, it's public void set gross sales, double sales. Again with our brackets. And we're going to set it to gross sales equals sales less than 0.0. We're just initializing it, or we're setting it, because we're going to declare the actual value later on. We want this to be, like I said, the parent or the superclass, and that way later on we can reference it and make changes to it. And this will be a good point to pause and explain again why we do the private variables. If we did this as public variables, say we did public or protected double gross sales, then any modifications we do with later subclasses of this super parent class is going to mess up our program. It's going to make it very fragile. But if we set this to a final value of just set gross sales, and then we declare it as this, it's looking for a value in different classes and subclasses. It doesn't know exactly what the value is. That means that later on in different classes, we're going to specify the amount of gross sales per employee. That's why we call the public get gross sales amount, and then modify that instead of the actual variable. And I'm sorry if I'm not explaining this very well. As most of you know, I'm not a programmer and I'm learning Java at the same pace as you guys. But as I learn more information, I'll definitely keep you updated, and if you have any questions, please leave a comment. I know this stuff can be pretty abstract sometimes. For now, we're going to end set gross sales. And then public double get gross sales, brackets. Let's do return gross sales, and then end get gross sales. Now let's set the commission rate. Set commission rate. Again, we don't know what the commission rate is. Let's say we know it's between 0 and 1, or maybe a different rate, 6%, whatever it is. We want to make sure that we want to have data validation, or variable validation, if you will. That way user can't put letters or something crazy in there. So we're going to set the commission rate. We're going to do public void set commission rate. Again, double rate. Let me do double because we're not working with integers, we're working with money, and we want specificity up to several decimal points. We're going to use 2. When we output the data with system.out.printf for formatting. And here we're going to do commission rate equals rate greater than 0.0, and here's one of our logical operators referred to a previous video for a review of the Boolean and the logical and the conditional operators. But we're going to use a double AND. This is basically called a circuit breaker, because it's going to evaluate the left side, and if it's true, it's just going to skip the right side. correct me if I'm wrong. But it's more efficient and the same thing as the previous one, because again, we don't know the exact value, so we don't want to declare that. And set commission rate. Now we're going to get our commission rate. We're going to return it. We're going to do public double get commission rate. We're going to do return commission rate. We're going to have to double check this pretty thoroughly to make sure there's no errors. And now let's calculate earnings. And we'll do this by public double earnings. And earnings are going to be calculated as return. We're returning a double here. Return get commission rate times get gross sales. Notice again, we're not calculating earnings by commission rate times gross sales. We have those variables declared up here and we can easily do this. However, we're using the get methods again because we don't know the exact value that's going to be declared later on. Maybe we want to use a scan class, that way we can receive user input. We can import that from the Java API, or maybe we want to declare it in a different subclass later on. Think of it like this. In the next video, we're going to create a basic class employee, and then we're going to have different employees. We're going to have an hourly employee, a commission employee, a base plus commission, and so on and so forth. The same thing with if we're working with a geometric program, right? We have two-dimensional or three-dimensional shapes. Two-dimensional, we're going to have a circle, a square, or a triangle, and three-dimensional, we're going to have a sphere, cube, and a tetrahedron. And the main or the superclass is going to be a shape, because all of those are shapes. And we're going to have things that are the same, like border width, pixel length, whatever. And then we're going to go into different orders of specificity. But the main super parent class, that's going to be inherited to all the children classes, to all the subclasses. That's what we're doing here, is we're ensuring that we can have a good flexible program by calling on the get methods instead of the actual variables. And let's see how this, we'll see how this works later on. We're still working on, our first class. But let's end earnings. We're almost done, guys. We're almost there. Now we're going to return a string representation of commission employee object. Again, we're making sure we're annotating this, and it's going to be public string. Remember how we talked about toString, the class that we're going to invoke with the word this? We tap this and we implicitly invoke method toString of the object being constructed. That way we could obtain the object's string representation. This is what we're doing, and this is the class we're talking about, toString. This is an interesting class. Kind of the meat and potatoes of this one. Return string.format. And need to be careful here, %s colon, and then it's going to be %s. These are all string placeholders. That's all that is. %s, %s, /n, %s, %s, /n, %s, colon %.2f. This is for doubles here, and we're specifying 2 decimal places of specificity. /n %s colon %.2f. I think that should be it, comma, and now we can do commission employee get first name. Again, we're not referencing the variable itself. The variable is private, and to have a good practice, we're just invoking the get method. We're going to get last name, and we're going to have social security number. You can kind of see how this is going to be organized based on the format specification criteria we established above. Social security number, get social security number, and then gross sales. Again, we're going to get gross sales, and the commission rate finally. I believe that should be it. It looks like we have maybe 1 or 2 errors. Cannot find symbol, method, get first name. That's because we messed up. There you go. Now that error is gone. Capitalization matters, guys. And what does this one say on line 79? Add at override annotation. We'll deal with that when we cross that bridge. Alright. I think that's it. Let's end method toString. And we've ended class commission employee. We're going to revisit this again and go line by line and look at everything we've written. I know it's a lot of information we're covering today. It's going to be a long video, but stick with it. It's definitely good learning. And now we're going to take a look at base plus commission employee, and we're going to see how this class extends commission employee, so that we can think of this as our super class, and this one is going to extend it. And then the constructor test, that's when we're going to, that's our main class, and we'll take a look at those right now. This one is much easier. This is the base plus commission employee, and we're going to see how this extends commission employee. So we have our package declaration, and we declare our class. And here's where it gets interesting, because this is something we've never done before. We're going to do extends commission employee. Yeah, it's going to give us an error. Let's not worry about it right now. Let's do private double base salary per week. And we're going to have a 6 argument constructor because we're going to have a variable for double salary. So 6 argument constructor, public base plus commission employee, and we're going to do string first, string last, string SSN. Let's do double sales, double rate, and we ended there for a commission employee, but this one extends it. We already see how. Double salary. I remember in the first one how we calculated salary. Before we forget, let's end class base plus. I'm just going to put ... You know what it is. Here, let's do opening and closing brackets. Yeah, it's gonna give us some errors. Let's see what this one says. Constructor, commission employee, and class commission employee cannot be applied to given types. Required string, string, double, double. Found, no arguments. Reason, actual informant. Okay, let's see what happens. It's probably because we're missing a lot of stuff. So let's continue on. And let's do super for a super class. First, last, SSN, sales, rate. Set base salary. Salary. Here we're validating and storing the base salary. System.out.printf. Let's do /n base plus commission employee. Constructor. Remember how we're adding this in just so we know the execution order of each of our constructors. Let's do... No. I don't want to do that. Let's do /n %s /n this. That way we don't have to split a line. And let's end the 6 argument constructor. And here we're going to set base salary. Notice that we don't have to set anything. The parent class already takes care of that for us. That's why we're extending upon it. And all we have to do is set the base salary and calculate the earnings. So we're setting the base salary. Public void set base salary, double salary as our argument. And we'll do base salary equals to salary. And the same thing as before. Nothing's changed, because we still don't know what the salary is. Come on now, there it is. All right, and let's end. Now let's public double get base salary. Public double get base salary, return base salary. Let's scroll down a little bit so we can see what we're doing. And get base salary. Now let's calculate our earnings. Let's do calc earnings. Public double earnings. And let's do return get base salary plus super dot earnings. So we don't really have to do much here because we're using the earnings from the previous class. Let's go back to it. Let's go to commission employee.java. Let's go to, where is it? Earnings. Right, commission rate times gross sales. All right, we're still using that, but now we're just adding a base salary on top of it. So we're literally extending upon this class. So we're returning get base salary plus super dot earnings. Too easy. And then let's end calc earnings. Right, and what else do we need to do? We need to return a string representation of base plus commission employee. We're going to have our toString class. So let's do employee public string toString. Let's make sure we annotate this and toString. And here we're going to do return string.format again. And we'll do percent. I hate how it does that sometimes. I really don't care for some of the filler stuff. I'm typing it myself. Thank you. And we're going to do parentheses %s space %s /n %s colon % .2f, again two decimal points, 2 degrees of specificity, comma, base salaried, and then let's do super.toString because we're going to use the toString that we use in a main class, in our parent class. Base salary and get base salary. Right, and we've ended the method toString, and we've ended class base plus commission employee. Everything looks somewhat in order. We're missing these, of course, because we have nothing in the constructor test. And we're going to work on that right now. We're going to take a look at now how we fill in the information of the employees, the salaries, the social security numbers, and so on and so forth, and why we went through all this painstaking trouble to declare our variables private and then reference not the variables themselves, but the get methods. After we declare our main class with public static void main, we do commission employee 1 equals new commission employee, and in the parentheses we're going to type in the information. First name is Bob, last name is, and we're writing it in this way with just strings because those string characters that we're typing now are going to be import in the exact order that we wrote in these programs, namely when we go down here in our parent class is going to be first name, last name, social security, gross sales, commission rate. So in the constructor test class, ignore the errors that are popping up for now. Let's do Jones, social security. You can make up anything. And let's not forget the rate. All the salary and then the rate. I keep forgetting that it doesn't like 1,000 separators. And now let's do system.out.print on a new line. And then base plus commission employee 2. Remember, in the beginning of this program we said that we have 2 employees. One makes just commission and the second employee makes a base salary plus commission. So these are 2 employees. Let's do new base plus commission employee. Let's do Amanda, or it doesn't matter what name you pick. Something at random. Social Security again. Now remember what these numbers are. Let's go back to commission employee. First name, last name, Social Security, gross sales, commission rate, which we have here, gross sales, commission rate. And we have gross sales. Let's do even 5,000. Commission rate 0.07 and base salary of say 1,000. Believe that's right. Let's make sure. Yeah, the numbers don't really matter. Now let's end our main class, and then let's end our constructor test. And that should be everything we need. Variable employee 1 is not used. Not sure that's true. Let's find out. Let's go over all of our programs. We have a few errors. Add override indentation. Let's run it and see if we get any errors, and if so, what kind. Let's click the run. If it works properly, we should see an output just like this. Build successful. Perfect. This is exactly what we want to see. Let's analyze this input and see what it's telling us. So on the first execution, we have commission employee constructor. So now we know that it's calling this constructor. Remember the keyword that we use, this. It's using this constructor right here, the very first file, commission employee. The commission employee is Bob Jones with social security number 000 and so on and so forth. He made $10,000 in gross sales and his commission rate is 5%. Next, now the program continues to execute. You know, it's reading line by line, program by program, or file by file, I mean. Commission employee constructor, we're still on the same file. Base salaried commission employee is Amanda Stewart with social security number this, gross sales of 5,000, commission rate of 7%, base salary of 0. Let's see what happened here with Amanda Stewart. I'm not sure it's supposed to be 0. Actually, yeah, it is. And then base plus commission employee constructor is on this file here, and we have a build successful. Alright, if I can explain this without confusing you further, this is what's going on. When the program first executes, it looks into the parent class commission employee constructor, and the first employee we have is a basic commission employee. We don't need to go to our base plus commission employee class.java. We don't need to do any of that. So the first one looks in the first parent or superclass and outputs all the information that is necessary. The second one, Amanda Stewart, this is the intermediary step. We need this step because we're pulling all of the information from here. And notice I was wondering why it said base salary 0, and I thought it was wrong, but it's not. This is there's a reason why we put these statements here. Let's go to the print statement up here. System.out.printf commission employee constructor this. Every time it executes this specific constructor, it's going to create a string representation of it in our output. Let's run it again and then look at our output. This is what it's doing. The first time around for Bob Jones, it goes through it and then it stops. There's nothing more to be done. The second time, however, we're dealing with base plus commission employee, an employee that has a base salary plus a commission. And that's the class that extends upon our parent class. So what it does is it goes into the parent class, it pulls in all of the information it needs, all of the information that's inherited. Remember, we didn't set or get any other methods except the base salary and an calculation for salary in our second file in the base plus commission employee. Everything else, the name, the social security number, gross sale, and the commission rate, everything was done in the parent class. So this intermediary step has to go back to the parent class, execute that constructor to pull out all the inherited information, and then it moves forward to the base plus commission employee class. This is a very crude explanation, so feel free to leave a comment and correct me if I'm wrong. But then it goes to this file here and it continues on and it executes this. So before it executes this constructor, the base plus commission employee, it has to execute this constructor here. the commission employee, where we have the first name, last name, social security, gross sales, and the commission rate, because those are all things that are going to be inherited by this employee. And we'll see that in the next video when we're dealing with hourly, commissioned, and salary employees, that they all inherit things from a class called employee. And this is basically where all of the information is contained. We could have very easily just imported java.util.scanner and created a user input so that we can input the first name, input the last name, input the social security number for each employee. That would have been a more roundabout way of doing it, because if we already have employee records, if we already know what's going on, then maybe we're importing an Excel file or something like that. But for now, let's pretend we know all the information and we're inputting it. This last piece here, the $1,000 in salary, notice in the intermediary step, we don't know this because it's going to the commission employee Java, and the base salary is set to 0, because again, everything here for the salary is, where is it, earnings and everything we don't know what it is, so we're setting it to 0. So that's what happens when we run it, is the base salary is 0 because we don't know what it is yet. And when we go to the base plus commission employee and we go to the get method for the base salary, we find out that it's 1,000. So if we were to get rid of those print statements that create a string representation of the constructor, we would not see this middle step. This is kind of the middleman. This is something that would happen in the background and we wouldn't see it. We would see this. We would see just this last one and just this first one. So that's it for this tutorial, guys. If you have any questions or comments, please leave them below. Thanks for watching, and as always, I'll see you next time on our College Designs production.